Let's talk about how to use Excel to solve the linear programming problem. A company manufactures two different sizes of bolt lifts. The small lift requires 1 hour in the welding department and 2 hours in the packaging. For the large lift, 3 hours in the welding and 1 hour in the packaging. The company has 150 hours a day available in welding and 120 hours in packaging. Here we give several profit functions. For the variables, let x be number of small lifts, y is the number of large lifts. This is constraints based on the question. So 150 hours in the welding. Small lift need 1 hour, so 1 times x, plus large lift need 3 hours in the welding, so x plus 3y less than and equal 150 hours. For the packaging, small one is 2 hours, and the larger one just 1 hour. So 2 times x, 2x plus y less than equal 120. And this is object function, is just our profit function. We gave 3 profit functions to see the result. This video is related to our another video. We solved the exactly same problem by Python. So you see, this is exactly same problem. And we have the conclusion. Based on the example, the solution is only among the boundary points except the origin. So we have 4 boundary points except the origin 0, 0. One is 0, y is 50, x 60, y is 0. This is intersection point is 42 and 36. And no matter what the profit function is, and the solution only could be the boundary point. So if this one or this one and this one. Now let's verify this result by our Excel way. This is a table to describe the problem. Welding 1 hour each, small lift 3 hours, each large lift. Packaging is 2 hours and 1. And this is the used hours. See here the different color like green and the light yellow and this gray color for matching the different profit functions. And available hours 150, 120. And this is profit. We want to get the maximum profit. So now let's set up the cells. For the used hours is 1 hour for the small lift, so equals 1 times x plus 3 times y, because 3 hours for each large lift. Now you see this is 0 because we not started solving it. So x, y initial is 0. Now the packaging is equals 2 times x plus 1 over for the large, so times y. Enter. So the initial is 0. Use hour is 0. Now we need to go to this cell for maximizing the profit. So equals 25 times x, how many small lifts, plus 90 times y. Enter. So initial is 0. Now click the data tab. If you don't see this solver toolbox, you need to go to File, Options, and go to Add In. And you see the Excel Add In. Oh, and check this box, Solver Add In, then OK. Then you go to Data tab, you will see the solver. So click that. Now first, we need to input the objective. So this cell is here. And then we choose maximum, so max. And by changing variable cells, so changing this x and y, so the amount of small lifts and the large lifts. So is this both cells? Next, we need to add the constraints. Add. The first one is the cell reference is this use hours for the welding department. is less than and equal 150, so 150. The second constraint for the package department is use hours less than and equals 120. Okay, now we choose this linear programming method and we click solve. Then you keep solve solution. Okay, so we get 0, 50, 4500, and 150, 50. So the first profit function, the answer is x is 0, y equals 50. So this boundary point. Let's see the second profit function. How many small lifts and how many large ones to maximize the profit function. And similarly, the used hours is times x plus 3 times y. Enter. The second one is 2 times x plus 1 times y. Enter. And the profit function equals $25 for each small one plus $40 times enter. Let's go to data tab. Solver. We could just reset all. Objective. The cell is here. This one. And the max. Choose max again. And changing the variable cell is use both. The constraints here is use hours for the welding and less than equals 150. Then OK. Then add another one. So is here use hours less than equals 120. So here the just same in simplex linear programming. Then we solve. Get the answer. So the 42, 36. You see this boundary point. Let's do the last profit functions in terms x plus 3 times y. Enter. 2 times x plus 1 times y. And the profit function is 100. So 100 times x plus 10 times y. Enter. And the same, the data solver, and we reset all. Here the objective, the cell is this one, and the changing is this x and y. And add the constraints. The first is this use hour less than and equals 150. Another one is here 120. So okay, and let's solve. Now you see we get another answer is 60, 0. So is this 60 x is small, lifts 60, but no, we don't produce the large lifts. Then we get the maximum profit. But our conclusion is same as another video we solved by Python. No matter what the profit function is, solution always a boundary point 0, 50, 40 to 36, 60, 0. I hope this video helps.